Okay, I hope you can hear this all right. I thought the volume was lacking a little bit in the last video that we watched in regards to programming the drag racer. And since I had so many groups successful with that after I had shown the video, I am ready to move on to one more task before we end the trimester. So we're going to refer to this one as Task 3, Grandma's Chair. Your mission. Grandma is too old to get up and down the stairs on her own. Your task is to design an elevator that Grandma can sit on to ride up and down the stairs. Grandma needs to have a switch that is mounted on her chair to start the ride up or down when she is settled in and ready. Bonus for you overachievers out there. If the chair stops midway, always return the chair to the first floor after Grandma pushes the button. This will be a challenge for me as well. Another bonus, use line follower sensors to determine when the chair is at the top and bottom of the stairs. We used the line follower when we were learning about the test beds. Here's your duty titles. The mechanical engineer. You must design an elevator that Grandma can start that will automatically travel from the first or second floor by converting rotary motion into linear motion. The angle of the stairs is 30 degrees. I'm not going to require you to sketch your solution on a lab sheet. I'd like to see you folks get right to work and do some problem solving to put this together. The electrical engineer, you must work with the mechanical engineer and computer engineer when wiring the limit switches, Grandma's start-stop switch, and the elevator motor. Complete the wiring diagram on the lab sheet. So I will hand out another lab sheet like you saw in the first two activities. Now the purpose of the limit switches is to tell Grandma's chair where it should stop when it reaches the second floor and where it should stop again when it reaches the first floor. So think about when you were doing the spinning sign and you used the trigger switch to stop the sign. So you pushed a button, the sign spun, and then you hit the trigger switch and it stopped. The idea here is Grandma's chair is going to run into the trigger switch and the program's going to end. So how many trigger switches do you think you're going to need? If you said 2, that is correct. Grandma's start-stop switch and the elevator motor. Complete the wiring diagram on the lab sheet. Computer engineer. While the other engineers are busy working, you must write a program that will run the elevator up and down the stairs. Remember to start out by opening the PLTW template and do a save as. Call it Grandma's Chair to your directory. Be sure to fill out all the information like you've done on your previous projects. So let's look at some examples that I copied for you. Different ways to convert linear motion or rotary motion into linear motion. Some of these examples are outside the realm of what we looked at when we were studying mechanisms. If you remember, we used a rack and pinion to convert rotary to linear, and we used a lead screw. In this first example here, it's a simple chain and sprocket. However, we see that we have some metal hardware set up at 30 degrees, like defined in the task sheet. You should be able to identify some common hardware pieces in this illustration. Where we find the linear motion is this basket right here is supposed to exemplify Granny's chair. What I want you to look closely at, right in this area here, is a limit switch. So as Grandma's chair is going up, it's going to hit the limit switch there to stop the program. I also want you to identify there's another limit switch right here down below that's supposed to simulate the first floor. And then here's the push button for Granny to actuate the chair. Okay, remember how I used that example of the lead screw? Here's an application for Grandma's chair. Here we see the lead screw. It is set at an angle on a base plate. So they actually used 2 base plates to create the foundation for this project. They are missing the switch on Grandma's chair. They do have the 2 limit switches. Something interesting, you can see some bevel gears over here. So if you see the gold screw in the back there on the base plate, it is actuating the bevel gear that is in turn going to actuate the lead screw at 90 degrees. So since the lead screw decreases speed, they used a larger drive gear for the bevel gear to kind of jump that speed back up so that Granny's not hanging out too long in her chair trying to get from one floor to another. Here's one that looks more like an elevator. So it is not at an angle, and they do have some buttons set up, but this would not be a good example of student work like the first 2 I shared with you. So think about why this example here would not work out well. If you said it's not at 30 degrees, like the first 2 examples, you are correct. Because if you remember from the task description, Granny's chair is supposed to be angled up at 30 degrees. It'd be kind of like a stairway. If I go down here a little bit, I want to show you that if you go to YouTube and you type in Vex Grandma's chair, there's a lot of short videos on student examples. And as you look at some of these student examples to think about what you'd like to construct, please note they are going up at 30 degrees. There has to be some type of basket that would simulate Grandma's chair, and you'd want some limit switches at the end to turn the program off. Let's look at one of these video examples. So there's the button. Note the limit switches. Did you see how that worked? They used one of those spacers, and as Grandma's chair approaches that spacer, the limit switch hits it and turns the program off. So what we have here is we have an Intel bump, we have a start motor, we have an Intel touch, and we have a stop motor. So some really good examples there for completing this activity. So, again, let me minimize out of this, go back up to my Word document. What I've shared with you is this handout. It does have the mission on it. Please make sure that you do make reference to it. I've given you a couple of examples here to look at. And also, think about doing some research so that you can problem solve how to complete this activity before the end of the trimester. So until next time, good luck.